Hello, in this video, I'm going to go over how to determine if something is a function or not. So before we talk about what the word function means, we're going to backtrack a little bit and we're going to talk about what the word relations means. In math, all sets of ordered pairs are called relations. Here is an example. We know this is a set because they are listed in brackets. We know that ordered pairs are made up of an x-coordinate and a y-coordinate. As we study functions more, though, we're going to be referring to them using different names. The x-coordinates are also referred to as the input or the domain. So in this example, the 1, the 3, and the 5 are our domain values because they are the x-coordinates. The y-coordinates are also referred to as the output or the range. So in this example, the 2, the 4, and the 6 are our range values because they are the y-coordinates. So now let's take a look at what the word function means. Functions are a special type of relations, and if you could see from the diagram, it's a subset of relations. All ordered pairs are called relations, and then functions are a special type of relation where each element in the domain pairs with exactly one element in the range. What this means is that every input has exactly one output. Now, that's the formal definition, and I know it may sound confusing, but what we need to know when we're studying functions is that to determine if something is a function or not, a domain value cannot repeat. So the domain, remember, being our x-coordinates, cannot repeat for something to be a function. So let's take a look at a relevant example. This is what's called a mapping diagram, and we can see on the left that there are 6 students listed, and we can see on the right that there are 2 ages. So let's assume that all the 8th graders in a class are either 13 or 14 years old. So we can see that each student has one arrow drawn from their name to one age. We know Brandon is 14, Kaylee is 13, Ryan is 13, Emily is 14, Colton is 13, and Amy is 14. So this is an example of a function because every student can only be one age. Now that makes sense to us. So mathematically speaking, we look at examples of functions and non-functions, but in the real world, this would make sense to us. So this is a function. Would it make sense for a student to be both 13 and 14 at the same time? Well, no, we cannot have one student that is matched to the 13 and 14. You cannot be 2 different ages at the same time. So there are 5 representations of relations and functions that we're going to look at. We have a set of ordered pairs, a table, a mapping diagram, which is a little bit newer to us, a graph, and an equation. So now we're going to look at 2 examples. We're going to look at one that shows us examples of a function and one that is not a function. So in the first example, we're going to look at a function. So here first we have a set of ordered pairs. It's only 2, but we can see if we're looking at the domain values, which are x values, they are both different. They do not repeat, so this is a function. Now we can use this same example and represent it different ways. So here's a table. It gives us the same information. It's just a different representation, but we could still see that the x values are not repeating and they are different. So this would be a function. This is an example of what the mapping diagram would look like. The circle or the oval on the left will be our domain values or our x values. The circle or the oval on the right would be our range or our y values. And when we're listing our coordinates from this, we follow the arrows. So the -2 is mapped to 1 and the 6 is mapped to 3, so those would be the coordinates. Now we could plot those 2 points on a graph and we can connect them with a line, and we could see that every point that would fall on that line would have a different domain value. We studied linear equations this year, and every linear equation that we graphed was a function with exception to one type, which we'll look at on the next slide. This would be the equation of that line. If we plugged in any number for x, we would always get a different answer for our y value. So here's an example of a function represented 5 different ways. This is an example of a relation that would not be a function. So here we have a set of ordered pairs, and we can see that the domain values, or our x coordinates, are the same. So that would mean that this is not a function. This would be how it would look in the table. Again, we can look at our x's and see that they repeat. We are never concerned with our y's. I think it's important to note that the y values can repeat, and it would be a function. We're only concerned with the x's, or our domain values. Here's an example of the mapping diagram. It looks a little bit different because there's only one number in the domain. And that's because that one is mapped with two different outputs, or two different range values. The one goes with the -2 and the one goes with the 3. So that would not be a function because it's mapped to two different numbers. Now, here is our graph. So like I said before, every linear equation we graphed this year was a function with exception to vertical lines. Vertical lines are not functions because every point on that vertical line will have the same exact domain value. So we can see in this example, there's 2 points listed, but every point on that line will start with a 1 for the x coordinate. So that would not be a function. And then the equation of vertical line graphs always start with x equals. So in this case, it's x equals 1, meaning that every x value for this graph would be a 1. So this is an example of a relation that's not a function. Now there's something called the vertical line test. This is used to test whether or not a graph represents a function. If a single vertical line can ever touch the graph in more than one place, then it would not be a function. So let's take a look at what that means. In this example, the graph is the green curved shape, and we can see that there are 4 orange dashed vertical lines drawn through. Every vertical line only touches the green graph in one spot. It will never touch it in more than one spot. So this would be a function. Every domain value on that green graph would be different. Here's an example that would not be a function. As you can see, the vertical line drawn crosses through the green graph in 2 different spots. So therefore, this is not a function. It does not pass the vertical line test. The domain values at those 2 points would be the same, and therefore that is why it cannot be a function. But we can use the vertical line test to clearly see that. Here's an example that's also not a function. If we draw a vertical line, we could see that it actually crosses this graph in 3 different spots. So all 3 of those domain values would be the same. So the last thing I want to go over is how to explain your answer if you're asked to determine if something is a function or not. So if something is a function, there's 2 valid responses you can use. If you have an set of ordered pairs, or a table, or a mapping diagram, you could say that the domain values or the x values do not repeat. It is very important that you clarify domain or x, though. You cannot say it does not repeat. You have to make sure you are clarifying that you know it is the domain values or the x values that are not repeating. Or if you have a picture of a graph, you can use the explanation that it passes the vertical line test, and that would be acceptable. If something is not a function, it would basically be the opposite. You could say that a domain value or an x value does repeat. So again, you can't say it's not a function because it repeats. You have to clarify that you know it's the domain or the x value that repeats. Or if it is a graph, you can say it fails the vertical line test or it does not pass the vertical line test. So I hope this clarified a little bit how to determine whether something is a function or not a function. And in the next video, I'm going to go over how to determine if something is linear or nonlinear. So I hope this helped. Thanks for watching. See you soon.